We need to talk about one specific week, back in January 2026, because it might just be the week that quietly but completely changed the future of AI.
I mean, seriously, think about that. A dozen breakthroughs, all at once? It sounds like something out of a movie, but it's exactly what went down. We're not talking about just another product launch or some boring research paper. No, this was a perfect storm. We saw huge leaps in the AI models themselves, the hardware that actually runs them, and even where they're starting to show up, in the real physical world. So, let's get into it.
All right, first up, let's talk about the AI models themselves, the brains of the whole operation. For what felt like forever, the race was all about one thing: size. Who could build the biggest, most massive model? It was like a heavyweight boxing match. But then, during that 1 week in January, bam, the rules of the game just completely flipped.
And this right here, this captures a huge power shift. Because on January 26th, Alibaba dropped a new model that did something incredible. It didn't just go toe-to-toe with the big Western players, it actually beat them on a really important test for reasoning. All of a sudden, we had a new leader in the clubhouse.
Just look at these numbers. There's this benchmark. It's called Humanity's Last Exam, or HLE for short, and it's designed to be really, really tough. It tests an AI's ability to do complex reasoning. Well, Alibaba's new model, QN3, scored a 58.3, and OpenAI's latest and greatest, GPT 5.2, it got a 45.5. That's not just a small gap. This was a massive signal that Chinese companies weren't just playing catch-up anymore. They were actually starting to pull ahead.
Okay, but here's where it gets really cool. The score's one thing, but the how, that's the real story. It wasn't about building a bigger engine, it was about building a smarter one. We're talking about innovations like test time scaling, which is a fancy way of saying they could make their models smarter without having to do a full, crazy expensive retraining. And then you have stuff like long context stability. Basically, the AI can now read and remember a whole novel's worth of information to solve a problem. Plus, Meta figured out how to slash the cost of running these things. The takeaway? Brains were finally beating brawn. Clever engineering was the new king.
And you know what? That changes everything. Because a super efficient AI isn't just a cool science project. It's cheaper to run, it's easier to put, everywhere, and that shift is so important. Because once AI becomes practical and affordable, the next question is obvious, right? Okay, so what do we need to build to actually run this stuff at scale, all over the world? And that single question, it lit the fuse on an absolute gold rush for infrastructure.
So suddenly, we've got these incredibly smart, efficient AIs ready to go. So the whole industry just pivots. They stopped focusing so much on the brains and started obsessing over the brawn. The race was officially on to build the picks and shovels, the actual hardware to make this AI-powered world a reality. And the numbers, the numbers were just staggering.
$20 billion. Let that sink in for a second. That's the price tag on a licensing deal between NVIDIA and a company called Grok. This wasn't just pocket change. It was a giant flashing sign that even the king of AI chips, NVIDIA, needed very specific, very fast hardware for something called inference. See, training an AI is one thing. That's a huge upfront cost. But inference is what happens when millions of us are actually using the AI second by second. That part has to be lightning fast and super cheap. This deal was proof that the industry's focus had shifted to making AI a real, practical, everyday tool.
And the spending spree didn't stop there, not even close. On the same day, a quantum computing company called IonQ dropped $1.8 billion to buy its own chip factory, Skywater. Another huge bet on owning the hardware of the future.
Now, this wasn't just companies throwing money around. No, there was a crystal clear strategy behind it all. You had NVIDIA protecting its turf by grabbing that specialized hardware for super fast inference. You had IonQ deciding, hey, we're going to own our whole supply chain so they could speed up their quantum computing work. And then you had other giants like Hitachi bundling everything together to offer what they're calling an AI factory, a one-stop shop for big companies.
And that move by IonQ, that's a textbook business school move called vertical integration. By owning the factory that actually makes their chips, they get to control everything. No more waiting on suppliers, no more quality issues. They're in the driver's seat. It's the kind of move a company makes when a technology goes from being a cool lab experiment to a serious industrial-scale business.
So that's the big takeaway from all this spending. These weren't just big deals. They were signals. The entire industry was shifting gears, moving away from just R&D and into full-blown production mode. They're laying the foundation, the actual pipes and roads, for a world where AI is just everywhere. Which, of course, brings us to our final piece of the puzzle.
Okay, so let's recap. We've got these smarter, way more efficient AI models. We've got the massive infrastructure being built to run them. So, what's next? Well, the next logical step is for AI to escape the data center, to break out and start interacting with the real, physical world.
And when I say break out, I mean that literally. In fact, the first new frontier for AI wasn't even on this planet, because on January 27th, something happened that had never happened before. A large language model was actually deployed in space, in orbit. This was a huge deal. Remember that Alibaba model, QN3, the one that beat GPT 5.2? Well, they sent that very same model up to a satellite. It ran a task up there and beamed the result back down to Earth. The whole round trip took less than 2 minutes. And get this wasn't just a one-time stunt. It's the first step in a plan to build a constellation of 2,800 satellites, creating a global AI compute network in space. So, at the same time AI was literally reaching for the stars, it was also planting its feet firmly on the ground. This is when NVIDIA CEO Jensen Huang made a now famous declaration. He said that physical AI, robotics, was having its ChatGPT moment. What he meant was that it was suddenly exploding from a niche research topic into a real commercial thing. And you know what? He was totally right. This isn't some far-off future anymore. Hyundai is literally putting humanoid robots onto its assembly lines. Waymo's driverless taxis have already done over 10 million paid rides. Aurora's self-driving trucks? They're hauling real freight down highways in Texas right now. The magic behind all this is a technology called Vision Language Action, or VLA. It's the piece that connects what a robot sees with what a language model understands, which then allows it to take a physical action. It's the missing link that finally lets a robot hear, "Hey, pick up that box," and actually do it.
Okay, let's zoom out and put this all together. In the span of just a few days, we saw 3 massive things happen at once. A completely new kind of arms race for AI models, a mind-blowing gold rush for the hardware to run them, and AI finally breaking out into the physical world, from space to our own roads. This wasn't just another week in tech. It was a genuine inflection point.
I mean, look at it on a timeline. The convergence is just stunning. On one day, a Monday, the entire AI model landscape gets turned on its head, and a billion-dollar bet gets made on quantum computing. The very next day, Tuesday, AI goes to space for the first time. Then on Wednesday, another corporate giant makes a huge move to build an AI factory. This wasn't a slow burn evolution. This was a revolution, and it happened in less than 72 hours.
And this really breaks it all down, right? The models got smarter, moving the goalposts from size to efficiency. The massive spending on infrastructure showed the whole industry was gearing up for production, not just experiments. And then AI started leaping off the screen and into the real world. What's crazy is how each one of these trends fueled the others. It created this powerful, accelerating cycle of innovation.
And all of this points to one single massive takeaway from that incredible week. The old idea of one single company, one titan dominating the entire tech world, that's over. The future isn't one king, it's a whole ecosystem of specialized players. You'll have companies that just build the best models, others that build the best chips, and still others that build the robots or the satellite networks. It's a whole new distributed world.
So that leaves us with one final, pretty mind-bending thought. The question we should be asking has changed. It's not who builds the best AI anymore. The real question, the one that will define the next decade, is this: who gets to build its entire world?